The ICC test is generally considered to be as difficult as the electrical contractor test. Both exams demand a high level of knowledge and a strong understanding of the electrical code along with fundamental electrical principles. The ICC test serves as a national certification exam administered by the International Code Council, often shortened to ICC. The primary function of the ICC test is to evaluate the knowledge base and practical skills of individuals aiming to secure an ICC certification, indicating their competency in relevant construction and safety standards. In contrast, the electrical contractor test is a state-level exam overseen by the state's licensing board. This test is specifically designed to assess the knowledge and capabilities of individuals pursuing an electrical contractor license, which permits them to legally perform electrical work within that state. The purpose of this difference between the two tests is that the ICC test is a national standard of electrical competence, whereas the contractor's test is more related to state laws and safety. While both the ICC test and the electrical contractor test are challenging exams that require a significant amount of preparation, their focus differs slightly, the ICC focusing more on broader code knowledge and the contractor's exam on state-specific regulations and practical application. To successfully pass either test, candidates should firstly have a strong foundation in electrical theory, including understanding circuits, voltage, amperage, resistance, power, and the relationships between them as defined by Ohm's law. Secondly, be intimately familiar with the National Electrical Code, or NEC, which outlines the standards for safe electrical installations. And thirdly, possess practical knowledge of electrical systems and components, including wiring methods, overcurrent protection, grounding, and bonding. Furthermore, effective test preparation involves several key strategies. 1. Thoroughly studying the relevant codes and standards books, such as the NEC. 2. Taking practice exams to familiarize yourself with the test format and question types. 3. Attending review courses or workshops to reinforce your knowledge and address any weak areas. 4. Understanding the specific requirements and regulations of the jurisdiction where you plan to work. Let's delve deeper into the key areas of knowledge required for both exams. Firstly, electrical theory involves a comprehensive understanding of voltage, current, resistance, and power. Voltage is the electrical potential difference between 2 points in a circuit measured in volts. Current is the flow of electrical charge through a circuit, measured in amps. Resistance is the opposition to the flow of current, measured in ohms. Power is the rate at which electrical energy is transferred, measured in watts. Ohm's law, expressed as voltage equals current times resistance, or voltage equals amps times ohms, is a fundamental principle that governs the relationship between these quantities. Secondly, the National Electrical Code, or NEC, is a comprehensive set of standards for safe electrical installations. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, bonding, and equipment installation. Some of the key articles in the NEC include Article 110.3, which covers examination, identification, installation, and use of equipment. Article 210, which covers branch circuits. Article 220, which covers branch circuit, feeder, and service calculations. Article 250, which covers grounding and bonding. Article 300, which covers wiring methods. Article 310, which covers conductors for general wiring. Article 400, which covers flexible cords and cables. Article 408, which covers switchboards and panel boards. Article 430, which covers motors, motor circuits, and controllers. Article 440, which covers air conditioning and refrigerating equipment. Article 500, which covers hazardous locations. And Article 700, which covers emergency systems. Familiarity with these articles and others is crucial for success on both the ICC test and the electrical contractor test. Thirdly, practical knowledge of electrical systems and components is essential for both exams. This includes understanding wiring methods such as conduit, cable, and raceway systems, overcurrent protection devices such as circuit breakers and fuses, grounding and bonding techniques to ensure safety, and the proper installation and maintenance of various electrical equipment. The ICC test and the electrical contractor test also assess knowledge of electrical safety practices. These practices are designed to protect workers and the public from electrical hazards. Some of the key safety practices include always energizing circuits before working on them, using appropriate personal protective equipment such as gloves and safety glasses, following lockout-tagout procedures to prevent accidental energization, and understanding the hazards associated with arc flash and arc blast. Arc flash is a dangerous condition that occurs when a short circuit creates an electric arc. Arc blast is a violent explosion that can occur during an arc flash event. Both arc flash and arc blast can cause serious injuries or death. To mitigate arc flash hazards, electrical workers should wear appropriate personal protective equipment, such as arc-rated clothing, gloves, and face shields. They should also follow safe work practices, such as maintaining a safe distance from energized equipment and using insulated tools. In summary, both the ICC test and the electrical contractor test are difficult exams that require a significant amount of preparation. To succeed, candidates must have a strong foundation in electrical theory, be intimately familiar with the NEC, and possess practical knowledge of electrical systems and components. Active test preparation involves studying the relevant codes and standards books, taking practice exams, attending review courses, and understanding the specific requirements and regulations of the jurisdiction where you plan to work. Additionally, candidates should be knowledgeable about electrical safety practices to protect themselves and others from electrical hazards. Let us talk about the importance of understanding specific code articles within the National Electrical Code, or NEC, because mastering these articles is crucial for anyone taking electrical exams. Consider Article 210.12, which deals with arc fault circuit interrupter protection, or FSI. This article mandates the use of FSIs in specific locations within a dwelling unit to protect against the dangers of arc faults, which can be a leading cause of electrical fires. Understanding exactly where FSIs are required, such as in bedrooms and living areas, and the types of circuits they protect is essential knowledge. Then consider Article 250, grounding and bonding. This article is fundamental to electrical safety. Grounding creates a low impedance path for fault current, allowing overcurrent protection devices like circuit breakers to quickly trip and clear a fault. Bonding, on the other hand, ensures that all metal parts within an electrical system are at the same electrical potential, minimizing the risk of electric shock. Understanding the requirements for grounding electrodes, conductor sizing, and bonding methods is vital. Next, let us discuss Article 310, conductors for general wiring. This article provides detailed information on the types of conductors allowed for different applications, their ampacity ratings, and the correction factors that must be applied based on ambient temperature and the number of conductors in a raceway. Correctly sizing conductors is critical for preventing overheating and ensuring the safe and efficient operation of electrical circuits. Also, consider Article 430, motors, motor circuits, and controllers. Motors are a significant load in many electrical systems, and this article covers the specific requirements for motor circuit protection, overload protection, and disconnecting means. Understanding how to properly size motor conductors, calculate motor branch circuit and feeder protection, and select appropriate motor controllers is essential for safe and reliable motor operation. Now, let us turn to Article 440, air conditioning and refrigerating equipment. Air conditioning and refrigeration equipment have unique electrical requirements due to their cycling operation and the presence of compressors. This article provides specific guidance on the sizing of conductors, overcurrent protection, and disconnecting means for this type of equipment. Correct application of this article is critical for preventing overheating and ensuring safe operation of these systems. Let's delve into Article 500, hazardous locations. This article addresses the special requirements for electrical equipment and wiring in locations where flammable gases, vapors, dust, or fibers may be present. These locations require explosion-proof or intrinsically safe equipment to prevent ignition of the hazardous materials. Understanding the different classes, divisions, and zones of hazardous locations, and the types of equipment approved for each, is critical for electrical safety in these environments. Let's now talk about Article 700, Emergency Systems. This article covers the requirements for emergency electrical systems, such as those used in hospitals, fire stations, and other critical facilities. Emergency systems must be designed to provide a reliable source of power in the event of a normal power outage. Understanding the requirements for emergency power sources, transfer switches, and distribution systems is essential for ensuring the safety and functionality of these critical facilities. Let's now discuss effective strategies for studying and preparing for electrical exams. Firstly, create a structured study plan. Allocate specific time slots each day or week for studying, and break down the material into manageable chunks. Focus on one topic or code article at a time, and don't try to cram too much information into a single session. Secondly, use a variety of study resources. In addition to the NEC, consider using study guides, practice exams, and online resources. Many organizations offer courses and workshops that can help you prepare for electrical exams. Thirdly, take practice exams. Practice exams are a valuable tool for assessing your knowledge and identifying areas where you need to improve. Take practice exams under timed conditions to simulate the actual test environment. Fourthly, review your mistakes. After taking a practice exam, carefully review your mistakes. Understand why you got the question wrong, and make sure you understand the correct answer and the underlying concepts. Fifthly, join a study group. Studying with others can be a great way to learn from each other and stay motivated. Discuss challenging topics, quiz each other on key concepts, and share your knowledge and experiences. Sixthly, manage your time effectively. On the day of the exam, manage your time effectively. Read each question carefully and make sure you understand what is being asked before you attempt to answer it. If you are unsure of an answer, skip it and come back to it later. Seventhly, stay calm and focused. Test anxiety can be a major obstacle to success. Take deep breaths, stay calm, and focus on the task at hand. Remember that you have prepared for this exam, and you have the knowledge and skills to succeed. In closing, remember that both the ICC test and the electrical contractor test are challenging exams, but with proper preparation and a solid understanding of electrical theory, the NEC, and practical applications, you can increase your chances of success. Remember to prioritize safety in all aspects of your electrical work.